This conference will now be recorded.
So welcome everyone to another OCP Tap session. Today we have Vipin. He's going to give us a presentation about their work with the SyncESMC. Before we go further, Elad has some updates about some ongoing contributions. One is called RCB, standing for Receiver Carrier Board, and one is called LOF for the large oscillator form factor. Basically, the RCB is we're trying to standardize these guys, so like it makes it easier for interoperability and things like that. And then for the LOF is basically these. So Elad, please give us some more details.
Yeah, thanks, Ahmed. So as Ahmed mentioned, we're trying to enhance the hardware specifications when it comes to the time card. And now we're looking into these two modular standards, the RCB, Receiver Carrier Board, and LOF, Large Oscillator Form Factor, in effort to make them, in effort to make our innovation of the hardware and our adoption of the hardware faster. We would like to standardize on the interfaces and standardize on the mechanics and the layout, so that we will be able to benefit from the community and the scale that we can all contribute together. The two specifications, we try to keep them as to the minimum, not to over specify, not to limit the vendors and the operators who are looking to either develop or adopt them. We put some thought as to what would be the minimum requirement so it will be interoperable, but not limit or inhibit any type of innovation. So the specs were sent out in an email to you guys. They're also on our GitHub, and do funnel your feedback. The main developers for that would be Ahmed and his team over at Facebook, as well as the different vendors who are listed in the document. And we do appreciate the feedback. We also expect, so one more thing, we also expect that this will be iterative. We consider this as a 0.1 type of spec, where probably we will be able to beef it up once we get further adoption and proliferate on more of instances of RCBs and LOFs. Yeah. Ahmed, you wanted to add something? Did
Yes.
I miss anything?
So basically on the RCB, we've been having a lot of, we don't want to restrict anyone. We just want to make enough. We want to give everyone freedom to do all kinds of things. Like for example, El Proma has done these different modules of not only GNSS, like there is these modules that they can receive from 5G, or we have Nobu is trying to basically put the YY module in this form factor. We have an SDR coming in this form factor. And then for the LOF, for example, we have the normal, like the what OCXOs used to be, like, I mean, this is a rubidium clock, but then we are making like these boards, it's all open source, available on the time card. So like you can have OCXO, TCXO, all of them, they can sit here. So let's say when you make these boards from different vendors, you can simply just swap these modules with no changes. Also from NVIDIA, we have a suggestion to have a smaller version of the, let's say, the RCB, but that's going to come further down when we basically put this up. Again, it's available on the two links a lot shared over there. And all of these things will basically will be kind of, let's say, baked in as suggestions, but not like mandatory. When we go with the PAR P3335, which working with Kang on that, so that's that's the standard, the IEEE PAR basically we're aiming for by IEEE. Anything else, Elad?
No, that's it.
And Kang, let's see.
We are thankful for everyone who helped us to get this far, and we look forward to see that spec go out. We will take it through the processes of the OCP committee and keep you posted.
Yes. And Kang, do you want to add anything for P3335?
Yeah, we are planning a, I guess the project has been approved by IEEE NESCOM New Standard Committee. We are planning to have a kickoff meeting in March the 7th. But right now, the a call for participation is being worked out by the IEEE publicity people. They will distribute it, and as soon as we receive it, we'll forward to everybody interested.
Wonderful. Thank you, King. Anyone else? Anything else before we introduce the speaker? Hearing none, let's introduce our speaker. So Vipin founded the company and like before that he worked like over 20 years in networking and telecom industry, and he holds a master's in computer applications. So Vipin worked in Broadcom on XGS and DNX timing solutions for Linux PTP and Broadcom proprietary PTP stack. And also Vipin is associated with the Brocade data center platform and timing solution development. Also, Vipin has worked with semiconductor companies like ChanSwitch, Motorola, Freescale, and Telecom and networking products. So with no further ado, Vipin, the floor is yours. Make sure you unmute.
Yeah. Hi, thanks. Hi, Alan, and hi, thanks to OCP Tab for giving this platform to present us and present our solutions for the timing solution that we are working on. And we are really thankful that. So today's topic, we want to present that timing and the ITU-T standard, the SyncESMC based on the ITU-T G.8264 multi-clock ESMC implementation, which we have done. Before that, I'd just like to go and then give some small introduction to the company, like what we are doing and what we have started at. So SyncMonk, we have is an early stage bootstrap startup founded in 2020, and we are based in Bangalore, India, and with main focus on timing synchronization services and products. And we are working on the complete integration services to telecom networking, some of the semiconductor companies in India here. And we believe in the innovating things and working on the time services portfolio, including software and hardware solutions. Some of the software solutions which we are working on, like the one is the SyncESMC, which we are presenting today. The FishEye, the clock monitoring tool for sync and timing solutions, and the Sync PTP, which is again the PTP stack for the IEEE 1588 2009 that thing. So I would like to say this, since we got this platform, and I would say the thanks. When we started, it was a COVID time, and it was like a lot of support we got it from the companies like the Sankhya Labs in India, who are working on the 5G ORAN platform. And we got the good support from the Greg Armstrong from the Renesas, who gave the chance to work on Linux PTP announcement for the some of the 75.2 profiles, which we worked on that. So let's that is a thanks to everyone for supporting us and then giving a chance to work on the same time. And definitely we will keep on innovating on that front. So this is what the thing today's agenda, to move to the agenda. So in the agenda, we will just go through that, what is the overview of the ESM SyncE and ESMC, which everyone aware of it, but for the everyone's knowledge, we'll go through the overview. What is the SyncESMC, why we designed, what are the goals we had, what is the architecture we have chosen for that to make it more generic and work with the different hardwares, hardware abstraction layers we have designed, and external interface, and we have it have the inbuilt monitoring support, so which get integrated with the FishEye tool, and the demo video which we have created for the YouTube for the presentation of that. So an overview, when we see that there is a in the network, we have the SyncE when the one of the master clock gets synchronized based on the SyncE, and the complete network, does all the nodes, the sync Ethernet based on the frequency will be transmitted to the each and every node and get synchronized. But the frequency doesn't know that what kind of quality it is. So the quality need to be transmitted based on with the help of the ESMC, which is the logical channel, which transmit the SSM information that what kind of quality it is getting from the master. That SSM information determine the quality level of EEC, that Ethernet equipment clock, and this is based on the 8264 and the 781 that profile we have selected here. So Ethernet SSM is the ITU-T defined Ethernet slow protocol. It's based on the slow protocol it works. Now the network topology, the picture credits we have taken it from Wikipedia, which from the Sync page. If here you can see here the master clock, which is providing the clock could be at the PRS or PRC, and the slave clocks could be the EEC or the SSC or SSCB based on the network option. Now there could be the multiple place, like we can see there is the requirement, like could have the multiple path can be there for the one of the node, or there is a node can have take the multiple clocks. Now there could be a selection mechanism that which clocks should be selecting based on the number of hops or the quality coming from the its source, another source, multiple source it's coming. So all this has been covered, and it's also need to avoid the different loops in the network. Also, it should make sure that thing it should not transmit the clock back with the same clock, so that it should avoid the loop as well. So this we have designed the SyncESMC stack, like which we have in the Linux PTP is there for the PTP stack. There are the ESMC implementations, but they are not completely addressing all the hardwares. So we have designed the SyncESMC with hardware abstracted ESMC stack, which is completely able to plug into any hardware platform with the help of the HAL layer, and it's compliant to G781 and G8264. We have chosen the simplified single-threaded architecture and interaction with the PTP stack because to support the interworking framework, so that PTP stack can provide the clock quality and which can be transmitted over the ESMC to support the EIWS support. Along with that, like we came up like it's required the dynamic configuration support, so that in field, right, if required some of the part we can go and update the configuration based on the requirement, and based on that if we see that some of the quality, like later on, that if we see that is the requirement based on the analytics, we see that some network changes, we can go and configure the network. Monitoring with FishEye, like some of the one of the goal, as I said, like we want to keep it the network over the monitoring from the day one. So we have built in the monitoring support for that. And currently we the SyncESMC support the Intel E810, Renesas ClockMatrix, and AuraSemi 5508 PSC. This is the overall architecture which we say that thing. The architecture is like it's have the state machine, which I'll go and cover it in the subsequent slides. The ESMC state machines, the timers, and the packet engine, and the HAL layer. So this is what the overall architecture gives, and we have designed this such a way like you can connect with the REST API, and you can connect with the for the keeping in mind for the next 5G generation and net configuration as well. So some of the design goals were like it should be a single-threaded architecture because it's low, very less packet rates, and it's not going to be too much heavy load process. So it's a single-thread architecture. Supporting the multiple hardware clocks, support using the HAL layer. Along with that, supporting the multiple clocks, like you can have the multiple clocks, one clock from the Intel and clock from the from the Renesas, or the maybe this design somewhere like we designed for some other vendors as well. External mux for the input signals, which may be the one of the requirement for the from the market, like where we have the clock can have the less input, but it's required the there can be a multiple source for that. We'll see that in the online. And it's really designed to support the kernel drivers. Like we have seeing that thing same like the Linux PTP or the PTP, where the Linux has supporting the PTP calls for the in the kernel, inbuilt kernel. We see that thing there is a requirement for the ESMC also need to go into have where we can the synchy quality and other things, where the loss of signal, loss of frame and all that thing can be supported. So those kernel driver related supports also we have kept in mind, so that with minimal changes, once the kernel driver have some certain functionalities available, we can go and quickly plug it with the kernel, and this stack will work with that as well. Interaction with the multi-vendor PTP stack, so that can any stack we can interact, and monitoring support, and it's a microservice compatible, so we can run this SyncESMC in the Docker, and that Docker is also available on we have made it available for the trial purpose, and that can be used for the Sonic as well actually. So configuration now, we kept the configuration have we kept the configuration the JSON and the RESTful API, so supporting in such a way like in the today's ready for the next level configuration as well. So have the two modes. One is the static configuration, and another is the dynamic configuration. The static configuration is completely based on the JSON file, JSON-based configuration. And it's whenever the system boots up, it boots up with the predefined configuration if the user want, and you can have the multiple clock defined the ports, and you can define the hierarchy directly. So each port you can give the different priorities, and based on the priority, it will supposed to go and select the port for the other thing. And configuration is majorly classified if you see in the what kind of device it have. So you have the device. In the device, you can have the multiple ports, and what the monitoring support you want actually. If you want to enable the monitoring, you can enable the monitoring in your configuration file. Some of the dynamic configuration which can be changed like on the fly, like you can add the ports, you can add the devices through the REST API and the NatConf YANG model for ORAN support. Along with that, like on that, we designed based on the API, so that you can build your own CLI. You can integrate with any CLI, or you can have on the web-based interface for that, or any northbound interface you can go and configure using these APIs. The packet engine is involved with the interface related activity interface, whatever that we see here. The packet RX part, packet TX, and port link up and link down events, and the packet filtering part. So you may have the packet, some of the ports can be defined as the RX and RX TX, and some port can be defined only as a TX. That's the provision we have kept it there. So it works on the different socket interface type, like it's a raw socket, UDIS socket, and the APIs. So packet engine, even that what we see that in the configuration is nothing else for us with the packet, and that packet will be in the packet filter. We will go process it and then pass it to the application to further actions actually. So that even that your link down, link up events also comes as an event for the packet to the packet engine, and which will make the action on that application. Now, if you see here in the this is the core of the ESMC stack. There is a state machine. So it handles all the state machine for handling all the port states, whichever the ports are there, even the clock state, which state it is. If it's in the PLL state, it looks into the PLL states and what is the state of that, whether it's in the lock state or whether it's in still and the in sync synchronizing state. So it interacts with the packet engine configure configuration engine and HAL layer, and decide to select the whichever the source port is the best selection port selection algorithm based on the selection algorithm. When we talk about the extended ESMC, first check the whether it's a quality, and then ports, and then number of hops it have. So based on that, it will select the which is the best port it is, and then based on that port, it will be selecting as a master port for that clock. It handles the different timer interrupts for the timeouts and hold off timer, and when the no activity on the port holdover, that's issue, and holdover timeout and the restore timers as well. It also interact with the HAL layer to configure the hardware, like when it is getting the some of the like loss or LOS event, then the out of frequency and PLL loss event as well. So some of the inputs, like it will be like the PLL ID and input for the selection instructions will be passed to the through the HAL, so that it will be which port need to be selected, that will be covered there. This is one of the external mux for the input signals, which with the multiplexing, where it can be configured for the number of source available for the PLL, and the maximum number of input which can be given to the PLL. Like, so in this case, like there is a number of let's say there are more than two based on the, like say the PLL can take only the 2 input, but there are number of source inputs are more than that. So it can run the external on the external mux. It can go and configure on the based on the mux. So if the device, one of the device in the configuration will be the mux actually, and the mux will be selecting the best port on the mux. Now based on that, let's say there is a 3 port. Now it will see that with 3 ports out of 3, which is the best ports are there. So it will go and select that, and then pass it to the mux for the PLL. It runs an algorithm on the mux basis to select the best port, and based on the priority programs for the mux there actually. It works with any available hardware where the number of input to PLL more than the number of sources available. Like some of the example, like we have the Broadcom XGA chip, where the data center switch you have number of ports are more, and then PLL can take a port or 2 ports there. So that's the design idea behind the supporting the external mux as well. So as I said, like hardware abstraction layer, as we are supporting the multiple hardware with the SyncESMC, it provides the hardware abstraction layer. So it have the well-defined function calls which need to be defined by each hardware vendor. And once they define the hardware vendor, that the stack will get plugged in with that with SyncESMC, and we are able to handle the hardware, and we can get the hardware event as well, like interrupts, then status monitoring, and the SyncESMC can monitor that and can take the further action while selecting that PLL that again ready for the kernel expose this thing for expose the API for the future controlling the hardware, and multiple vendors PLL can be controlled by the same stack actually. So you can have the if you have the multiple PLLs in your setup, like or in your device, it can go and control the multiple PLL actually. It's not be like only single PLL, it can go and control. So that's what we have kept in the mind. Some of the external interfaces we defined, like the UDS socket can be used to interact with the external applications for the PTP stack. So since PTP stack would be running on the same machine, so we have decided to use the UDS socket, and it will be interacting with the UDS socket. At the same time, we have defined some of the external interfaces as well for the configurations. Like you can have the remote configuration or remote monitoring as well for the FishEye part. So that is the reason that some of the interfaces are the external interfaces which can go and can be used for the external monitoring, configuration, and control. That's like once we design that thing, like we have defined, it's a automatic get integrated with the FishEye, which is our tools for the config for the monitoring the clock network actually. So it gives that complete, it builds the once the SyncESMC running, it will be building along with the PTP, it will be running, building the full network diagram, like network topology on that. It shows that thing whether it's your node is giving the which quality and what quality it is running as of now. So any node goes for the on the bad node, like it will go and the it will as it come as a red flag that's there. It also gives that your network summary, like you can see that there is a clock quality will be there, what kind of clock quality currently it is running with, what kind of node type, whether it is running as a SyncE or SyncE plus PTP or only PTP nodes as well. We are using the extended TLVs here because we in the ESMC there is no concept of the clock ID on that, but we have used the extended TLV that so that we can have the clock ID support that. It support that ESMC source, whether it's the line source, whether it is an external or it's a GNSS support. So it gives the complete details whether which node is supported with which that thing. On top of that, it will say that thing what is the kind of clock performance you are getting. If there is any alarms, if it's any alarm, then it will say that it's an alarm. What is the current SyncE source, current clock qualities? So you can go into within the clock and see the detailed view of the clock level, whether the clock is synchronized or whether it's still not locked state actually. Same way, like you can go and look into the port performance, where you can see that how many the packets, what's the activity on the ESMC, RX, and TX packets, along with that the PTP, the counters as well. Actually, if there is a PTP counter, and you see that whether the SyncE state and the synchronization state, how it is behaving at that thing, and any other alarms will be raised there. It will can be taken care by that thing. Same way like the clock details, or so some of the features are like plugged in with the PTP stack. So we have the, it looks into the system's time, system uses and temperatures and other things, so that you can get the proper understanding of your system, and at the same time the clock performance as well. I'll just take your time for 2 minutes to show that the demo which we have hosted on YouTube. Maybe this will give you that how the system will be selecting the clock when changing from the one external to internal, and how it goes with that actually. So just
welcome to SyncESMC.
so you can see the logs on your left side, and the commands which we are running on the you can see the port has been changed, synchronized port, the GNSS 0.
Watching. For more information,
Yeah, thanks a lot. If you have any questions, I'm open for that.
Great. So let's start with questions. Anyone questions? Basti, I think this is like your world. Yeah.
Hello, Ahmed. Hello.
You want to start? Right.
Hello.
Hi.
Can you listen me, Vibin?
Yes, we can.
Yeah, Lokesh. Yes, Lokesh,
Yeah.
I can.
So I do have a question regarding to ESMC protocol.
Yes,
Like I had seen that you also addressed the timing loop.
right.
So for the timing loop, what kind of solution have you suggested?
Uh, so you are talking about this, the loop which we are talking
Yeah.
about here?
Yeah. The timing loop.
Yeah, so that is what we are seeing that thing, the node when we are selecting here. We are seeing that one of the node will be when we select the node in the algorithms, actually when we give the select the priorities, the based on the priorities we see that thing it's supposed to um, it goes and select that whether it's what kind of topology it is making actually. So when we make the graph internally, we see that thing that how the node will be collecting it to connect to each other actually. And based on that, we make sure that thing it will not get selected to the same source actually. So that it
Yeah.
passes the tree there actually. With external TLV, like that is what we have thought, like where the external TLV can pass it the some of the information, and we can go and avoid that loop there actually,
So
because
how
the
you have
SMC
so
will
how you
not
have
be able to, yeah.
so how you avoid the scenario of timing loop?
Right. So that is what, like once you have the node graph you have created,
Mhm.
then you may able to go and avoid that graph actually with that loop actually. There.
I do agree because this topology is very simple. But what about the complex topology where we have the subnetworks? In
Okay.
that case, the scenario will be completely different. I do agree because you are currently implemented the enhanced Syncy solution because
Right.
there is the concept of clock source ID. So by the
Right.
clock source ID, you are trying to avoid the same source to get selected again and again.
Right.
But in the subnetwork concept, the same clock source ID, I think that solution will not work.
Mhm. Okay.
So, Lokesh, I would like to add few things here. It's actually L2 protocol, so devices are directly connected here. So and it is a requirement that the clock ID will be unique in the network. It cannot be the same thing. I mean, in the network, it cannot be same. So if you have different subnetworks, in that case, the clock IDs in the different subnetworks will be different, and they will have different master clocks. So we don't need to take care about the different subnetworks. And second thing is like another thing that is considered is the MAC address. So from the source MAC address from where the packets are coming for the ESMC are also considered for identifying the loop in the network.
But okay, I do agree partially with you, but I think this is not the right platform to ask so much detail about this. That's okay. I do understand your concept.
Yeah, if
Sure,
you have
maybe
any
Lokesh,
questions,
we
you can
can,
write to us.
yeah. Yeah,
Yeah.
Lokesh, we can connect and then we can brainstorm on that and then try to solve that as well. Actually, yeah.
I have one more question, like how
Okay.
you have addressed the defect loss of signal.
So
Detect
that
loss.
loss of
Yeah, go ahead.
signal is basically coming from the hardware. So hardware has most of the hardware generally have those APIs or way of detection. So we are using the hardware APIs or hardware registers to identify those things.
Yeah, I do agree, Devashish, but there is a
Yeah,
thing because there is only one hardware, DPLL, that can only
right,
detect the loss of signal.
right.
But what if we have the number of ports and DPLL is always connected to one frequency? And if one of the signal get failed, how the DPLL get address this
So,
issue?
what happened like the location like usually in the hardware like whenever the any time the signal whenever the frequency recovery happen, that recovery will be passed to the one of to the DPLL engine. So let's say like the DPLL will be having the two in clock. So even the you have the clock recovery and in the hardware enabled, like in the FPG or the ASIC, you will be sending the two lines to the hardware to the DPLL engine. When they see that thing, there is no clock coming in. Actually, it will go and then flag it that it is not, it is out of frequency or out of signal actually. So once it see that it's out of frequency, let's say like the you will break the link, it will supposed to see that out of frequency there,
Yeah,
or that will
yeah,
be flagged to the ESMC stack.
yeah, I do agree with it. But actually, it can only address the two links which are directly connected to DPLL. But what about
Correct.
the other ports? If there is some loss of signal to other ports, that
Right.
loss of signal will not be addressed.
So if you are talking about the multiplex scenario where you
Yeah,
have the
multiplex.
multiple
Yeah,
mux,
yes,
yeah,
yes, yes.
right. So in the mux scenario, if we go into mux scenario, right, what happens is let's say like there are the four ports there actually, right? In the four
Yeah,
ports, what you it is designed in such a way like the request per requirement, like it is like out of four ports you have given the set the priorities actually. So the four ports have the priority the one, two, three, four. Now you have selected one and two for
yeah,
the best port, right? And once you have the one and two selected, and that will be given to the your PLL engine, right? Now, let's say what you are saying that thing, and hypothetically one will go and the signal will be lost on the one, correct?
yeah.
It will be go and select to number three actually. So what we observe it on the mux selection, the if there is a loss of link will happen, it will go and start the run the priority algorithm and see that thing which link better clock
Uh,
is there and pass it to the next link actually.
I do agree, Vipin. I think this is the hardware limitation because according to G.781, the defect loss of signal cannot be addressed on all the hardwares because there is only one DPLL. So the
Right,
DPLL can only address one of the port connected
correct,
port, not
correct,
regarding to the all the ports. So I
correct.
think there is limitation in that defect.
Right. So we look into the loss of link. We monitor the loss of link there to make sure
Yeah,
that
but
when the
Vipin,
link is
loss of
lost.
sorry to interrupt. The loss of link, is it according to G.781? I haven't seen loss of link kind of defect in G.781.
It's not exactly this, but you need to monitor the loss of link, right? Once that is the one of the scenario where you will be seeing your frequency will be lost, right?
Yeah, the link up and link down, that is one of the
Correct.
subsequent action of for the signal fail. I do
Correct.
agree with this thing. That is the subsequent action for signal fail. But I think according to G.781, loss of link is not mentioned in
Right.
G.781.
Yes, it's not that.
Yeah. Okay, fine, fine. That's okay.
One thing we do when you have, let's say, I mean, in an ordinary NIC, when we want to, let's say, we have a customer, let's say, that is looking, and let's say in our setup where we have, let's say, a lot of time servers,
Mhm.
and we want to, let's say, get a consensus from all of them, is again, you have like one like, let's say, DPLL, or let's say even in the case of like free running, we just look at the projection of the, like, basically we assume the free running, and then we will look for the projection of those, like you can have multiple projections from a free running clock. I mean, you can have one of them that basically does real time, but the others can be just projections, and then with that we look at a consensus, an agreement from all the different like time servers, and depending on what the customer chooses, let's say in terms of availability versus consistency, which in this case, consistency actually is reliability. You're basically consistent across all the sources. Then you basically tune now the, let's say, the real time, something like that. Like, I think I don't know if that. What do you guys think about that?
Yes, yes. So that is something like which we need to get the more data on that, whether which kind of clock is the consistent actually, instead of that clock which is keep on breaking actually. Like if the link is keep on breaking, the frequency we keep on going actually, that the system will be actually keep on showing the fluctuation there actually. Like the better like to have the consistent clock compared to the clock which is going in the it's not consistent there actually that we are seeing actually. So yes, that is the one thing which, and then that is the one thing which we see, that thing which could be helpful with the help of the monitoring actually, because once you connect in the initial level, you don't have any data.
Yeah.
Once you start looking into that later on, once you build the data, then you can see that I have the consistent clock, and it should be automatically switched. Maybe that algorithms can go and pick up. Since this clock is more consistent, I don't see any breaks there. I can go and shift to this clock, and this is a much better topology for me actually in the network.
Yeah. Any more questions, comments? All right, we can actually finish earlier. So in 2 weeks, basically next in line, we have Tomasz, which he is going to tell us about the Polish trusted time distribution with authentication and verification. And after that, we have Rodney from NI, which is going to tell us about principles in precision time measurement. Hearing there is no more questions, I think we can, again, close earlier, give you 8 minutes back. So, any last thoughts?
Yeah, I mean, I just want to talk about, let's say, something we might try, okay, for some of these meetings. And you mentioned it in the beginning, just the round table, okay, if we can at some stage. So I think what would be really cool to try at some stage is just to give some of the smaller companies and the people who don't want to commit to the full sort of 1 hour talk an opportunity just to spend 15 minutes, okay? So I'm interested in hearing sort of what are people doing and what are people working on, even if they cannot spend the full hour. So if anyone wants to do something like that, just to give a brief overview of something which they find interesting or they want to talk about for say 15 minutes, get in touch with me, and we try and put some of these people together in one session. And yeah, I think that would be kind of cool.
Yeah, like if we get enough of those, we can bucket them in a session. That would be perfect.
Yeah,
And
that would
yeah,
be.
Kenny, anything you want to add?
I want to add something. This is Alad. So I think that's a great idea, and we can also add a spotlight as to the different work streams that we are making progress with here at SAP. So a lot of you are not able to join to these meetings, but we can use that little smaller slots to give an update of where we are and share your thoughts and opinions on that.
Perfect. Okay, great. So we'll see you guys in 2 weeks.
Ahmed, can you
Ken,
stay?
Yeah.
Yeah, no, I mean just talk with you later after you finish this.
I'll call you after this. Okay.
Okay.
Jeff, anything you want to add?
No, I thought.
Okay, great. See you guys
Thank
next
you.
week. Bye.
Thanks. Bye. Have a nice day.
Thanks. Bye.
Bye. Bye.